Howdy, this is planetscience.com. Yeah, obviously. Lightning. What causes lightning? What causes lightning? Lightning strikes. Have you ever got a static electricity shock or seen sparks when you take off your jumper? When lightning is made, the same thing happens, but on a much bigger scale. How does lightning form? Lightning is an electric current. To make this electric current, first you need a cloud. When the ground is hot, it heats the air above it. The warm air rises. As the air rises, water vapor cools and forms a cloud. So, first you need a cloud, and now they are explaining how a cloud gets formed. So there has been something before the cloud. When the air continues to rise, the cloud gets bigger and bigger. In the tops of the clouds, temperature is below freezing and the water vapor turns into ice. Now the cloud becomes a thundercloud. Lots of small bits of ice bump into each other as they move around. All these collisions cause a buildup of electrical charge. Eventually, the whole cloud fills up with electrical charges. Lighter, positively charged particles form at the top of the cloud. Heavier, negatively charged particles sink to the bottom of the cloud. When the positive and negative charges grow large enough, a giant spark, lightning, occurs between the two charges within the cloud. This is like static electricity sparks you see, but much bigger. Yeah, I really just read what's written here. Lots of small bits of ice bump into each other as they move around. Water vapor cools. Yet this is somehow like something really. I have been pondering all my life about this, like for many, 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 many years. As they teach us in school and stuff, that the warm air rises up, it is water vapor. Because it's warm, it rises up, and if it's high enough, it turns into ice. And I have been thinking always that, yeah, if it turns to ice, why it doesn't drop back down because it's not warm anymore, you know? So if something warm rises up, something cool should come down, but it doesn't. It just stays there in the heavens. And it didn't make any sense. Nowadays, I think I understand the whole process of clouds a little bit better because they are plasma, it's charged. That's why there's a cloud in the first place. There is a bundle of energy, as you can see, as cloud. And a somewhat similar thing is going on beneath the ground. Telluric currents and such. And as we have seen, the rather odd cloud there in Turkey, was it some 2 weeks before the Big Bang in Turkey? Actually, now I remember. I made a little post on YouTube, like just a picture and a text. Now, as I'm talking about Turkey, most of you are familiar with the East African Rift, like where Africa splits apart once then. They're expecting. It's approximately there. It might be many kilometers off, but just to show where approximately it is, according to the experts. I'm no expert. And I've been thinking, is there any possibility that they were wrong and it wouldn't start in Africa, it would start in Turkey? And of course, that's just total an imaginary line or whatsoever. It could go as well somewhere here, you know, or here. Or it might happen at all. I don't know. This was just something I was thinking about recently. But now back to this. Water vapor cools and forms a cloud. And the reason why I started to talk about lightning is this article I just stumbled across. I haven't really read this yet. Martian lightning could play a major role in the planet's chlorine cycle. 24th February might be today. Depends on where you live. Dust storms are a serious hazard on Mars. Yeah, for who? And it's just nature, as the nature is nature here on Earth or wherever you go in the universe. Anyway, while smaller storms and dust devils happen regularly, larger ones happen every year during the summer in the southern hemisphere and can cover continent sized areas for weeks. Once every 3 Martian years, about 5.5 Earth years, the storms can become large enough to encompass the entire planet and last up to 2 months. Ask yourself a simple question. If it's possible to have these kinds of events on Mars, why shouldn't these kinds of events be possible on Earth? What you need to get, or like, what does it need in order to get something like that? More energy. The Earth is connected to the Sun via the Birkeland currents. Every now and then they get visible with the polar lights, northern lights, what is it, Aurora Borealis, or in the southern hemisphere, Aurora Australis. So that's the energy current which flows through Earth. And the Sun is connected with its own Birkeland currents to the next bigger source of energy, which might be the center of our galaxy. And our galaxy center is connected to the next larger provider of energy, and so on. To a certain degree. So, how much energy possibly the universe could provide? You know, there's a whole lot of energy out there. But anyway, I drifted off a bit. These storms play a major role in the dynamic processes that shape the surface of Mars and are sometimes visible from Earth, like the 2018 storm that ended the Opportunity rover's mission. When Martian storms become particularly strong, the friction between dust grains causes them to become electrified, transferring positive and negative charges through static electricity. No water included, as there is quite likely no water included in volcanic ash plume lightning. It's just too hot. It's just dust. And if you think about volcanoes from a different perspective, there is this magma chamber and stuff underneath the volcano, which is connected to The electric currents which go through Earth's crust, mantle, and from the core, which are connected to the atmosphere, ionosphere, magnetosphere. Through all those layers, different layers will react differently. Some layers don't might react at all. And if there's a change, there might be reaction. According to research led by planetary scientist Alien Wang at Washington University in St. Louis, this electrical force could be the major driving force of the Martian chlorine cycle. Based on their analysis, Wang and her colleagues believe this process could account for the abundant perchlorates and other chemicals that robotic missions have detected on Martian soil. There are all kinds of stuff they've found, but not really water yet. Dr. Wang led an international team of researchers from Texas Tech University, the University of Delaware, the McDonald Center for Space Sciences, and Oxford University. The paper that describes their findings recently appeared in the Geophysical Research Letters. In it, Wang and her colleagues demonstrated how electrical discharge caused by dust storms could be responsible for decomposing chloride salts and creating atmospheric chlorine and other chemical compounds found on the surface. Chlorides, perchlorates, and carbonates. On Mars, chlorine is considered one of 5 mobile elements, the others being hydrogen, oxygen, carbon, and sulfur. Like Earth's water cycle or Titan's methane cycle, this means that chlorine is transferred between the Martian surface and the atmosphere in different forms. It exists in gaseous form in the atmosphere, while chloride deposits are found across the surface. These deposits are similar to salt pans found across Earth, like the Bonneville Salt Flats in Utah. I think I've been talking about this recently. I don't know. The Etosha Pen in Namibia and the Salar de Uyuni in Bolivia, the largest in the world. Similar to Earth, these chloride deposits are likely to be the dried remains of briny patches of water that existed on the surface. I know they are talking about water, but there isn't any. Still, there's lighting. It is theorized that they formed from interactions between the surface and atmosphere during the Amazonian period. Yeah, I don't know what's the Amazonian period. This geological era extends to this day. All right. And is thought to have begun with the end of the Hesperian period, about 3 billion years ago, when Mars was still transitioning from a warmer, wetter environment to what we see there today. Extremely cold and desiccated. Desiccated. Since there was no longer exchange between the surface and atmosphere, scientists have wondered how atmospheric chlorine and chloride deposits could be linked. Oh man, there could be so much talk about these just few sentences. In their new study, Wang, a faculty fellow with the MCSS, and her colleagues demonstrated that electrical discharges caused by dust storms are an efficient way for chlorine exchange between the surface and air. The possibility that dust storms might be a source of reactive chemistry on Mars was first proposed when the Viking 1 or 2 missions landed there in the 1970s. Wait, this is 53 years ago? I wasn't born there. No, I don't know if it's 70 or like whatever year. However, the chemical effects of dust activities were difficult to study since the ESA's Schiaparelli lander, which would study the phenomena, crashed on the surface in 2016. As a result, scientists have had to stick with climate modeling and experimental studies, including research that Wang and other planetary scientists have done in recent years. These have shown that when electrostatic discharges interact with chlorine salts in a carbon dioxide rich environment, like the Martian atmosphere, chlorine gas is released and perchlorates and carbonates can be generated. A dust devil on the surface of Mars captured on 14 March 2012. Yeah, there is an electrical current. It depends on the polarity, it spins either the one way or the other. And I think even dust devils on Mars are spinning. And it's just not some random circumstance. It's not like there would be walls or anything else, and the wind is blowing amongst the walls, and they start to spin because the wind gets direct. There's no walls on Mars, but yet still we have massive dust devil. Yeah, that's an electrical current which is connected to something beneath the surface. However, this latest study was the first time planetary scientists attempted to quantify how much of these chemicals are produced during Martian dust storms. This was done through a series of experiments at Washington University's Planetary Environment and Analysis Chamber, where the team subjected various common chloride mineral salts to electrical discharges under Mars-like conditions. Yeah. The similar thing could be made about Earth's atmosphere. Take stuff from our atmosphere, put electricity into that, and lightning creates ozone and stuff like that. Or destroys. As Wang indicates, yeah, actually, does it create ozone or not? Yeah, I said first I think it created ozone. The sense of a storm. Here is what lightning emits smell. The Washington Post. Where was it? Most of the atoms pair back up once the air cools, but some reshuffle. Some of the oxygen atoms combine with O2 producing O3, ozone. It's unusual to get large concentrations of ozone at the surface, and it has a distinct smell. It is noticeable right after a lightning strike. Like I said, they could do the same thing about Earth's atmosphere. Weather is entirely electrical. Frictional electrification is a common process in our solar system with Martian dust activities known to be powerful source of electrical discharge buildup. The thin atmosphere on Mars makes it much easier for accumulated electrical fields to break down in the form of electrostatic discharge. In fact, it's 100 times easier on Mars than on Earth. It's just different. It's the same thing. The reaction rates are huge. Importantly, the release chlorine in a short time mid-strength electrostatic discharge process is at a percent level. No other process that we know of can do this, especially with such quantitatively high yield of chlorine release. During a 7-hour simulated electrostatic discharge experiment, they found that at least 1 out of 100 chloride molecules decomposed and released the chlorine atom. In addition, the electrical discharge also accounted for the very high global concentrations of perchloride and carbonate compounds on Martian topsoil, though the formation rates were slightly lower, sub-percent per 1,000 levels. The experiment also showed that the observed concentration ranges could be accumulated within half of the Amazonian period. Lastly, the high yields could account for the high atmospheric concentrations of hydrogen chloride observed during the 2018 and 2019 dust storms, said Kevin Olsen, a research fellow at the Open University and co-author of the new study. The high releasing rate of chlorine from common chlorides revealed by this study indicates a promising pathway to convert surface chlorides to the gas phases that we now see in the atmosphere. These findings offer support that Martian dust activities can drive a global chlorine cycle. With the ExoMars Trace Gas Orbiter, we see repeated seasonal activity that coincides with global and regional dust storms. Another interesting takeaway from this study is how the team theorized what electrostatic discharges might look like on Mars. According to Wang, the discharge would not look like a flash of lightning, as it is the case on Earth. Instead, she said, it would be more akin to a glow due to Mars' thin atmosphere. Sounds like Aurora Borealis. It could be somewhat like the aurora in polar regions on Earth. Oh, yeah, I haven't read the article yet. Where energetic electrons collide with dilute atmospheric species, he said. To date, no robotic missions on Mars, be they landers, rovers, or orbiters, or chopters, or whatever, have witnessed an electrical discharge during a dust storm. The glows would be likely obscured by the heavy dust concentrations and not be visible from orbit. Meanwhile, surface missions that rely on solar power are forced to suspend operations in heavy storms to preserve power, as was the case during the recent storm season for the Ingenuity helicopter. But perhaps the nuclear-powered Curiosity or Perseverance rover could get a candid shot of this phenomena before their missions are complete. Otherwise, we have to wait on crewed missions. Yes, if the robots not can do it, now for sure humans can do it. Oh man. Robots are dying off because there's too much dust, so let's send some people there. To wait on crewed missions to see one of these aurora, which could lead to a Mark Watney-like situation, whatever that is. Yes, they have no clue what they are talking about. And what a oxymoron. Like, everything they have doesn't work if there's a dust storm, so let's send some people here. Take out your cell phone and make a selfie when there's a lightning strike on Mars. Or what do they think? But anyway, I think I leave it here. This is just something really odd. Here on Earth, they talk about that, yeah, you need a cloud first in order to get lightning, and water rises, cools down, and all this kind of stuff. It doesn't make really sense. Then we have volcanic ash plume lightning. There is no ice in those, there is like hot gases coming out of a mountain. There is no ice. And still, we have lightning. It's a connection from beneath the earth to layers of the atmosphere, which are all charged. Everything is charged. The ground beneath is charged. The ground above is charged. Maybe it's not ground above, but the layers. Yeah, there has been people in the past, they jumped out of airplanes in order to prove that you can walk on clouds. Yeah, they failed. But anyway, I'll leave it here. You can read the stuff by yourself in your own pace. But yeah, lightning all over the place. It's an electric universe, people. Thanks. Bye.